Our question is, an irregularly shaped piece of copper is placed in a measuring cup containing 3.5 fluid ounces of water. After the addition of the metal, the water level rises to 5.2 fluid ounces. If the density of copper is 8.78 grams per milliliters, what's the volume of a single atom of copper in cubic meter? These are the conversion factors that we can use. So first, let's subtract the final recorded water level, which is this one, to the initial recorded value to get our volume of copper. So 5.2 fluid ounces minus 3.5 fluid ounces. If we plug that in, we get 1.7 fluid ounces. Next, we need to make sure all units are the same, which in this case it is not. Let's convert fluid ounces to milliliters. So here we know that 1 fluid ounce is equal to 29.574 milliliters. So 1.7 fluid ounce equals to 29.574 milliliters, and this equals to 50.2758 milliliters. But this one has 2 sig figs and this one has 5 sig figs, so we need to do 2 sig figs, so it's gonna be 50 milliliters. Next, we need to find the mass of the copper. We know that the equation for density is mass over volume. So one thing I do to rearrange this equation is to make a triangle. Let me make this bigger. Like so. So we put density here, mass, volume. So for this one, we need to find mass of copper. So we multiply density to volume. Our density is 8.78 grams per milliliters times 50 milliliters, which is this one. So if we plug that in, we get 439 grams. But here we have 2 sig figs, and here we have 3 sig figs, so we only need 2 sig figs, so we can do 4.4 times 10 to the second power grams, or 440 grams. Next, we need to convert grams to moles because it's asking for atom. So grams to moles. Let's look at this chart that I made so it's easier to understand. mass to moles, we divide molar mass. We divide mass to molar mass. So we have 440 grams divide 63.546 grams, which is it's right here, molar mass of copper. So here we get 6.924 moles. So here we have 2 sig figs, and here we have 5 sig figs. So for this one, we only need 2 sig figs. So this is gonna be 6.9 mole. Now let's convert moles to atoms. Let's look at this chart again. So moles to atoms, we multiply it by 6.022 times 10 to the 23rd power. So 6.9 times 6.022 times 10 to the 23rd power atoms. And this equals to 4.2 times 10 to the 24th atoms. Next, we need to get our volume per atom. So let's use our unrounded value. So for copper, and divide that with our atoms. So 58 milliliters divide 4.2 times 10 to 24 atoms, and we get 1.2 times 10 to the negative 23rd milliliter per atom. So here we have our milliliter per atom. Next, let us convert milliliters to cubic centimeters so we can get our cubic meter. So here we know that 1 milliliter is equals to 1 cubic centimeters, so we just changed our unit to cubic centimeter. So 1.2 times 10 negative 23 centimeter cube per atom. Lastly, we convert it to cubic meter. So we know that 1 centimeter is equal to 0.01 meter. So we cube both, and we get 10 negative 6 cubic meter. So let's plug that in to this one. centimeter cube times 1 centimeter cube is equals to 10 negative 6 meter cube. So we this cancels out, this cancels out. So we multiply this and we get 1.2 times 10 negative 29 cubic meter per atom. So let's check our sig figs, 2 sig figs, and 2 sig figs. So our answer is 1.2 times 10 to the negative 29 power cubic meter per atom.